So we are doing geometry chapter 1 practice test, and we'll do some basic questions which have the basic concepts, and then we'll try to do more challenging questions towards the end. And we'll do some multiple choice as well as free response problems. Hello. So this is question 1. It is from 1.5. So point A lies in the interior of MNP if MNO is x square plus 10x and ONP is x square minus 2x and MNP is 3x square plus 12. Then you have to find the value of x and find ONP. So for this, we use angle addition postulate. You can check my previous video for of the class recording for chapter 1.5. So please try this problem on your own and then check the solution. If you have any difficulty, then also please check the solution. So O lies in the interior of MNP. So with the angle addition postulate, we can say that sum of adjacent interior angles equal the total angle. So let's substitute the values. So we substitute the values here and simplify. So we are getting this quadratic equation. When we factorize, we get x minus 6 times x minus 2 is equal to 0. So we get x is equal to 2 and x is equal to 6. So we'll check both the values to ensure that they both uh, produce positive angles that are valid in geometry. Now, when we put x is equal to 6 or test for x is equal to 6, MNO we get 96 degree, ONP we get 24 degree, and uh, MNP we get 120 degree. So this is angle MNP, we get 120 degree, which is a obtuse angle. Now let's try x is equal to 2. So now when we put x is equal to 2, we get MNO as 24 degree, ONP as 0 degree, and MNP as 24 degree. Now in strict Euclidean geometry rules, 0 degree inside is not allowed. We have to have a positive angle greater than 0. So we can ignore this answer. If the curriculum allows, then we can put it. Otherwise, it we will have the answer, which is x is equal to 6. This would be considered a valid answer. So our answer would be x is equal to 6 and O and P, which was asked in the question here, is 24 degree. Let's do another question. So this is the question. The measure of supplement of an angle is exactly 3.5 times the measure of the complement. So write the algebraic equation representing the relationship and solve for the measure of original angle. So if you want to go through the concepts, you can go through the videos for chapter 1.1 to 1.5. Here we'll directly solve the questions. So just please try on your own And after that, please check the answers. So let the angle be X and its complement will be C, which is 90 minus X, because complementary angles add up to 90 degree, and its supplement is S, which is 180 minus X, because supplementary angles add up to 180 degree. So complementary angles, they add up to 90 degrees, and supplementary angles, they add up to 180 degrees. So the supplement of the angle is 3.5 times the complement of an angle. Let's substitute the values now. So as we solve this, we substitute the values and solve the equation. We get 2.5x is equal to 135. If we solve, we get x is equal to 54. This was our original angle. We can check also. Now we see that complement we get as 90 minus x, which is 36, and supplement we got 180 minus 54, which is 126. We can see that 36 times 3.5 is 126. So our answer is correct. So this is question 3. So midpoint of a segment BW is 3, 4, and if the length is 10 and x coordinate of V is given, then you have to find the possible y coordinates of W. Please try this on your own and then you can check the solution. So the midpoint is given, the length of VW is given, and x coordinate of V is given. So we have to find all the possible coordinates of W. So first thing is we can find the x2, x coordinate of W. We can use the midpoint rule for this. So it's substituting the values, x coordinate of midpoint is 3, x1 is 6, and solving this equation, we get x2 is equal to 0. So this we get is 0. Now, what's the distance from the total distance was 10. So what's the distance of V or W to M? It is 10 by 2, 5. So the distance we have got, so we have got the distance VM as 5. Now we can get this y1 here because we have all other things. We have x coordinates, we have the coordinates for M. So only thing is we can get y1. So distance is 5 and we can use this distance formula here and substituting all the values for x1. So when we substitute the values and we solve, we get y1, two values for y1. It can be any one of them or both, like y1 is 0 and 8. Now since we have got y1, which can be either 0 or 8, and we have the midpoint, y coordinate of the midpoint, we can get y2 using the midpoint form. So in the midpoint rule, we used, and first we put y1 is equal to 0, which we got, and then we get, using the midpoint rule, we get y2 is 0, 8. When we put y1 as 8, we get y2 is equal to 0. So now the possible midpoints or the possible answers are, so the final answers are 6, 8 and 0, 0. For V it is 6, 8 and for W it is 0, 0. This is one pair and this is the another pair for VW. So first what we got is we found X2 or the X coordinate of W, we got it 0. So that is same for each. X coordinate of V is same for each. And then we use the distance formula, which is 5, we know, and we got two values of Y1 or two values of V coordinate, Y coordinate of V, which is 8 and 0. And then again we use the midpoint formula because now we got V and W both. We know uh, only y2 was missing and we know the midpoints. So we used 4 is the y coordinate of midpoint and we used both y coordinates of v 8 and 0 and we got 2 coordinates of y coordinates of w. So these are the two possible answers. So, screw lines are pair of lines that are not intersecting, means they never intersect like this. They are not parallel and they are not on the same planes. So let's do some problems. So this is a triangular prism given and we have to find which lines are skew. So we know skew lines are a pair of lines. They are not intersecting, non-parallel and non-coordinate. So first one is, this you can try on your own and then we can discuss the results. So first one is SB and TV. So they are intersecting. Then QR and QT. So they are also intersecting. So they cannot be skew. Third is QR and TB. So we can say these are non-intersecting. QR and TB. They are on different planes and they are not parallel also. So this is the result. We can say RS and RU, they are again intersecting. Okay, so the correct result is QR. These are the lines. Now let's do one Q. So this picture is given and which lines are screwed here. So let's try first one, IJ and JM. So they are not screwed because they are intersecting, they meet at J. So then KL, which is this, and MP. So this we can say because they will never intersect and they are not parallel and also they are not coplanar. So these lines are skew. Let's try other ones also. IM and MN. So these are intersecting. So they are not skew lines. And IJ and IM. They are intersecting. So they are not skew lines. So the correct answer is KL and MP. So this is a 3D intersection problem. So there are, suppose line M and N, they intersect at line K and P point lies in plane M but not on line K and Q lies on the plane N but not on line K. So if line M passes through P and Q, explain how line M interacts with K, line K. So just think over this problem and then I'll discuss the solution. So this is the visualization of the problem. See, this is line M. This is plane M and this is plane N and this is line K and they intersect at line K, which is this red color. And point Q, it lies on plane M. We can see here. This is Q. Okay, so this is Q here. And sorry, point P lies on the plane M. We can see this blue color is plane M and P lies here. Q lies in the green color here, this plane N here. And but they don't. Okay. So now there is line M which passes through P and Q. So explain how line M interacts. So we can see this is same as, so if we think we can see, uh, so see plane M and plane N are different planes. So here we can, this problem is same as in this cube, if it is easier to understand. Plane IJK that has a point P, suppose, and plane P OK has a point Q. So if we connect that, then what will be its, how it will interact with line LK, which is this line. So we can say that these lines are not parallel and they will not intersect and they are in the different planes. So these lines are skew lines. So same as with this, in this question, that these lines, line K and line M, they are not parallel, they are not intersecting, and they are not in a same plane. So they are the skew lines. So again explaining this, see line K lies in both plane M and N. Okay. Now point P is here. It lies on plane M but not on K. And point Q lies on plane N but not on line K. So because P and Q do not lie on the same plane as line K, line M, which connects them, is not coplanar with line K. And since they are not coplanar, they will never intersect and they are skew lines. So I'll add more problems to the practice test in a small bit of time. But please keep practicing and feel free to let me know if you need hard problems in any other topic. Thanks. Thanks for joining. Wish you all the best.